All right, ladies and gentlemen, let's take a gander at this warm-up. Before we do that, though, our goal today is that we're going to graph and solve a system of linear inequalities. So we've already done equalities before, or equations we call them, a system of linear equations, and so we can graph this one. So help us out here when we are graphing the first one. So our y-intercept for the green is -1, and our slope is 1 over 1. So up 1, right 1, etc. looks like this. And then we can connect the dots. La, la, la. So our y-intercept is 4, and then we go down to right 1, down to right 1, etc. And then we can connect the dots. La, la, la. So we have to estimate this solution right here, just because it does seem to be very clear right there. So I'm estimating right here to be my solution. It looks to be in the middle-ish, but not entirely. So the nice thing about this is that we don't actually have to estimate the solution because it doesn't ask us to. It just says graph the system, so we're good to go there. If you wanted to estimate that just because of practice, you don't have to. You can, but you don't have to. Next is that we're choosing a point that's above my green line here that satisfies this inequality, and then you're choosing a point underneath that satisfies this. So let's just see what points work. Somebody give me one that's below the line. So to test those, here we see if it works. So I plug a 1 in for x, for y, and plug a 4 in for x, and we get 1 is less than 3. Good, it does work. It is below that line, and it satisfies the y is less than. Over here, let's check. Put the 5 in for y, and so we get 5 is greater than 3 minus 1. So 5 is greater than 2, and that also is true. So notice that if I wanted to go above the line, I have a greater than symbol. And if I wanted to go below the line, I have a less than symbol. So that's a key thing that we're going to walk away with, especially as we are going to graph this system on our own. So what we're going to do is spend some time graphing the system of linear inequalities. So here are our steps. Number 1, we're going to graph each corresponding equation. So we're just going to convert them to equal sign and graph the lines. Pay attention, though. Pay attention when we graph these for is it going to be dashed or solid, right? So that's the key that you're looking at here. When we do graph them, make it dashed or solid according to the rules. Next, we're going to shade the overlap region. The overlap region. So in a moment, we'll walk through that. And then, of course, we're going to check a point. Like we said last time, though, is that we could have actually flipped this, and we could just check a point and then graph that region, okay? So, and we'll unpack that a little bit as we go. So let's look at this first one here. What are the solutions to the system y is greater than x minus 2, and y is less than or equal to negative x plus 1? So let's graph the first one as if it were an equation. As if it were an equation. So that would just be like this, y equals x minus 2. And this can all be mental if you wanted. I'm just writing it down so that you can refer to them in your notes. I know that my m is 1 and my b is -2. So down at -2 is where I place my point. And then I go up 1, right 1 for all those points there. And I can even go down 1, left 1. Before I connect the dots, I need to look and see that this symbol is greater than only, and because it's greater than, it's going to be dashed. It's going to be dashed. So when I do connect the dots, I'll do so dashedly. So let's dissect this one here as if it were an equation. At first, again, you don't have to write any of this when you're doing it. I'm just going to show it now. So the slope is -1, which can be interpreted as down 1, right 1. And The y-intercept is positive 1. So let's graph it over here. Positive 1 is here. We go down 1, right 1 a couple times. Or I could have gone up 1, left 1 a couple times. Before I connect the dots, I need to check my symbol. The symbol here has an equal to sign. So that means this is a solid line. So we connect the dots. La, la, la. Now, the next part is we just need to figure out where the shading happens. Where the shading happens. And just so that you can see, we have 4 areas here. We have 4 areas. I'll name these regions, and you might even see this on a standardized test of sorts. We have this region A, we have this region B, this region C, and this region D. And the question is, what is going to be shaded? So do I shade only the A right here? Am I going to shade only the B right here? Am I going to shade the C, shade the D, like that? Or is there going to be some weird thing that happens which won't happen probably in a situation like this? So as explained to us, we look over here and we see, oh, for the yellow, because Y is greater, I'm going to have to shade above. So that includes A and D. I'm shading those regions. But for the green, I have to shade below, which is these regions, the C and the D. The overlap is the D. So I'm going with the D. But let's go ahead and just do a quick test. Notice 0, 0 is a great point because zeros die easily. And we can test that. So let's just do a quick test before we actually shade. So the first one is 0 greater than 0 minus 2. 0, and I'm testing it with 0, 0. 0 is greater than negative 2, so it's a check. So it works for the yellow, which we expected because graphically we see it. How about for the green? Is 0 less than or equal to negative 0 plus 1? Is 0 less than or equal to 1? Oh, that is true. Perfect. So when we do the shade, if you are shading with a solid pen or something like that, you might want to shade so it looks like this, where you're just kind of like connecting things, and you're not spending a lot of time pressing hard. So I do not like it like this, like that, so it's all covered and hidden, okay? But if you can, do the side of your pencil or something, and it just ends up shading nicely, sort of like a highlighter, like I'm doing here, then that is a great thing to do. Notice that the shading goes on forever. It's just outside the grid there, right? So it does go on forever in that quarter of the plane. An example 2 here, is it possible to have no solutions? In other words, practically speaking, that would be no overlap. So let's see here. Let's take a moment to graph these two. The top one here begins at positive 2 and has a slope of negative 1. So it looks like so. And it is a solid line because of that equal. There we go. Now the next one, y is less than negative x minus 2. So minus 2 or negative 2 is there. And then we also go down 1, right 1, or up 1, left 1. But this time it's going to be a dashed line. Like so. Now logically speaking, let's see what we shade. According to the yellow, it says greater than the yellow, which would be this region here. Notice I only have 3 regions. I have the region above them both, I have the region between them, and I have the region that is under them both. So let's see, what can we shade? Well, the first one says that I am going to shade above in this region. The second one says I'm going to shade below. So the question is, what's the overlap? And the answer is, there is none. Because if I shade this way and I try to shade this way, there is no overlap. So in this case here, we get no solutions. I'm going to test that, and the only real way to test that is to test a point from all three of them. So I'm actually going to prove to you, in this case, that A, B, and C do not work. So let's check a region. If we check region A, I'm just going to randomly choose a point here. So it looks like 2, 2. I can check that. So I'll check 2, 2 there. And if we do check 2, 2, we see that 2 is greater than 0. So it does work for the yellow one. But then 2 is less than negative 2 minus 2. 2 is less than negative 4. So far, doesn't work. Let's try region B. And notice that region B here, 0, 0 is a nice point there. So I'll try 0, 0, see what I get. So trying the yellow one is 0 greater than 2. The answer is, I don't even need to go further. I don't even need to check the green one because it's already false there. So already doesn't work. So the last one here, and let's try negative 2. Negative 2, negative 2, negative 2. Notice that I'm going to check the yellow there as well. And in actual fact, I already know that doesn't work because look, if B doesn't work and B is under the yellow, then there's no way that C can work because that's under the yellow also. I'll go ahead and show that, but logically we've already proved it, that it doesn't work. So just to show that here, negative 2, and I'll try just the yellow one because we already expect that one to be false. So is negative 2 greater than or equal to 0? We expect not. I do want to point out to you that all those right there, you can just check in your head. Or notice that B and C already check the yellow there. So it ended up not... So A region works for the yellow, but not for the green. And B works for the green. It works for neither. And C works for the green, but not for the yellow there. Next, we're going to check the how to go the other direction. We're going to write the system of inequalities from the graph. So we're going to take one at a time, and I'm going to color code these so it's a little bit easier. So I'm going to call this guy my green line, and this my yellow line, and we'll do one at a time. I'm going to focus on the yellow line at first, and the yellow line here begins at negative 2. So for the yellow line, it begins at negative 2. So that means my B is negative 2. Let me unpack that a little bit just so you see it's mx plus b. So I can just put the negative 2 right there. We see that it is a solid line and we're shading above. Solid line and shading above like so. So that's going to be a greater than or equal to. And the last thing we need is just my slope. So if I do go to a next point up there and count off up 1, up 2, so the slope here would be up 2, and then right 1, which is also a positive. There's my slope. So all we have to do is put a 2 there for the first one. So just to review that here, the green line starts at negative 2, so there's my B. Then it goes up 1 and left 1, or another way to consider that is down 1 and right 1, which gives me a slope of negative 1. Solid line, so we have an equal, and we're shading above that, so we have a greater than. And this is my answer. Notice it's not my solution. I'm calling it my answer because the question was, what is the system? And the system is the two inequalities together. Your turn is to do each one of those below. Start with number 4 with a partner, and then work on 5 and 6 solo. Go. And you can check your work here. On this last page, we're going to spend some time with an application, and we just take it step by step, just like we did with the system of equations. So Malia has $500 to purchase water bottles and pairs of socks for a fundraiser for her school's cross-country team. She needs to buy a total of at least 200 items without buying too much of just one item. So what graph shows the possible number of water bottles and pairs of socks that Malia should buy? So we've got to give and figure out what her constraints are. So notice we've got 2 units. We've got 2 units. We've got something talking about dollars. We've got $500 as a total. And we also have socks cost $3 and the water bottles cost $2. Next, we have the number of items that we can purchase. The number of items total says we've got 200 items to buy total. So we have to define our variables first. You're welcome to use W and S or P, something like that, although it might be easiest just to use X and Y. So let's go ahead and do that. Let's call our socks X, the number of pairs, and let's call the water bottles Y, number of water bottles. I'm avoiding the S for socks because my S looks like 5s, although you could have done P for pairs of socks and W for water bottles. All right, so let's see. For dollars, well, we know that if you buy a pair of socks is $3 times the number of socks. That'll tell you how much money you've spent on socks. Next, we're going to add that to how much money we've spent on water bottles, so 2Y. And notice she has $500 to purchase, but she doesn't have to spend them all. So it's going to be less than or equal to $500. Now, the next part, we see that she needs to buy a total of at least 200 items. So what do we do with that? Well, if X is the number of pairs of socks, and actually let's change that. We're going to change this to Y, and we'll explain in just a minute as to why we're going to do that and change this one to X, which means these two are going to change here and here. In a moment, you'll see why. So it's still going to be X plus Y is going to be at least 200, like so. Okay. Down here, we can see why is because when we are finding the X and Y intercepts, for example, on this one here, if I found the Y-intercept, it would be 3y equals 50, which that would give me approximately 167, and that fits better on this axis right here. So we're just being consistent with Y over there. So we're going to call this the number of pairs of socks over here, and this guy down here will be the number of water bottles. To find the number of water bottles, we do 2x equals 500, so x equals 250. So let's go ahead and graph that first equation here. So at 167, which is approximately here, and the other one is 250, which is down here, and then let's connect the dots. Something like that. Now, of course, the straighter we are, the better results we're going to get. Now, the next one here, when I find the x-intercept, I get 200, and the y-intercept is also 200. So 200 here and 200 there. So let's go ahead and connect the dots, and we get something like this. So the next question is, where do we shade? Where do we shade? Well, notice here, because I have positives all across the board, that when I get y by itself, this symbol won't change because I'm not dividing by a negative. Same over here. I have positives across the board here, so when I get y by itself, this variable, this expression symbol will stay the same. So for the red line, we're going to go under, so anything under here. And for the yellow line here, we're going to be above, so it's going to be anything up there. So notice it's this region in between right here. Now there's also a practical aspect of things here. Notice that a sentence in here, or a phrase, says she needs to buy a total of at least 200 without buying too many of just one item. Too many of just one item. Well, that's sort of a subjective component here. But if she did buy only water bottles, it would be somewhere on this line here. If she bought too many water bottles, it'll probably be just here, because notice right here, at 50 pairs of socks, it's anything over there. So my guess is that if we were going to consider things, we would nix that out and focus just on this part right here and above, right there, in that region. So let's go ahead and just choose maybe 1 point or 2 points right there. Notice 150 of that, and then this one here looks like about 65. So we can do 150 water bottles and then 65 socks, pairs of socks specifically. And we can choose a whole bunch of other different points in there. All right, and the next problem is down here for you to work on. Attack, kill, destroy.